Hi, Mrs. Sulkson here. We're videoing from Amber's room. She's got a dry erase board, so I'm going to use this. I'm going to use the microphone, so hopefully you can hear me a little better. We're going to focus on the math today on acid base. I want you to bring out this worksheet. If you didn't pick this worksheet up on Friday because you were absent, I do have more on Canvas that you can print out. So the first thing you need to see on top and fill out is the equilibrium constant for water, which is 1 times 10 to the negative 14th, is equal to the hydrogen concentration times the hydroxide concentration. Remember that these brackets that I've placed here mean concentration. We've got hydrogen and hydroxide. So we're looking at, if we were looking at a solution, here's my beaker, my solution, which one do we have more of? That will tell us if a reaction or a solution rather is more acidic or more basic, or is it in a neutral? So if you have more hydrogen ions, then you're considered acidic. If you have more hydroxide ions, you're considered basic. So again, we're focusing on only the math in this portion of the video. So there's a little bit of math that we need to know and have, including your calculator. You should have your calculators out. You should have this worksheet, pencil, and your comp book if you want to write any extra notes down. So with that, we have an equation that's written that says pH. I want you to fill in that pH is the negative log of your hydrogen concentration. So in the calculator, you would press negative log and then whatever the hydrogen concentration is. Well, let's say you're not given the hydrogen concentration. In this worksheet specifically, I've given you pHs of all on the problems. So if that's the case, and we're given pH, and we are trying to find the hydrogen concentration, then we have to take the inverse log. So on your calculator, that typically the inverse log would be the second function log. So you'll press second function log. So let's say you're given pH, you'll put second function log, and then you type the negative pH. And that will give us the hydrogen concentration, or some people call that the hydronium concentration. So in the crash course information, it does refer to both of them. So let's do pH of number 2. So pH of 2, type in your calculator the second function log, negative pH, and you'll get an answer that some of your calculators will read 0.01. If you put that in scientific notation, you just move the decimal point over, so it's 1.0 times 10 to the negative 2. All right, so on a pH scale, the next portion asks you to calculate OH concentration. Well, we know from above that 1.0 times 10 to the negative 14th is equal to both of those concentrations multiplied together. If we know the value of our hydrogen concentration, and we know this value, and we're looking for the concentration of OH in our solution, we can then just divide the numbers. So it becomes a math problem, truly a math problem. So we'll set up the equation to look like this. And what do we get for our answer then? Type it into our calculator, and you get negative 12. It all should make sense because negative 2, negative 12 should equal a negative 14. So when we're dealing with numerals that are 1.0, that does make a little bit more sense. But I want you to understand the math that's involved as well. The final portion of this assignment asks you, prior to deciding if something's acid-bases, is trying to calculate pOH. So we've always talked about a pH scale, but again, in our crash course video in Khan Academy, we have a scale from 0 to 14, and then there's a 7 in the middle. That section from 0 to 6.9 is acidic. Excuse me. 7.1 to 14 is considered basic. So if we know that our pH in this question that we started with, pH is 2, we can take 14 minus 2, which is our pH, and we're given our pOH is 12.